Hello people, welcome back to my programming series. Today I want to feature Racket, which is a type of Lisp. Actually, it's a scheme which is a type of Lisp. And so I wanted to highlight Lisp in this video. Lisp is the second oldest high-level programming language, created in 1958, and it essentially revolutionized programming. It had features that didn't make it into other programming languages until recent times. So it was only in the past, say, 10 or 15 years that C++, Java, C#, and a few other languages started using features that Lisp introduced in 1958. And for this demonstration, I'm actually going to use Racket. Racket has a great IDE, and it has a huge standard library. It's a great way to learn Lisp, or a type of Lisp called Scheme. And so you can just go to the download page and pick your distribution, which I would just pick Racket. And then whatever platform that you have, your 32 or 64-bit and your operating system. You just download it to your system, and then after you download it, you double click on the package. At least in Windows, you can double click on the package and it'll run an installer, and you can just follow the install wizard and install the Racket program. And once it's installed, you can run it and you get this program here. This top part is kind of a workspace where you can type in your code and you can actually save it to files. And this bottom part here is a REPL, so it's a read eval print loop where you can interactively program in the language. And there are a few buttons along the top. One that you will use most often is probably the run button, and then maybe the stop button if something is running too long. One of the first things you want to do when you start up Racket is you want to make sure that you want to have laying Racket here as the first line. It normally starts out with no language at all. You can type this in, or you can do choose language and click on the Racket language radio button and click OK, and that should put it in there automatically. So Racket actually allows you to build other languages, which is why you can have this hash laying. You can actually build your own language if you wanted to, but we're going to use the Racket language. And what we're going to do is go over some of the original parts of what made Lisp great. So Lisp, one of the founding or building blocks of Lisp are atoms. So they're things like numbers and strings, and those are essentially the major items here. Now Lisp actually stands for list processing. So everything in Lisp is essentially a list. And so a list looks something like this. Let's see, let's go down here and we say 1, 2, 3, 4, 5, and that would be a list. Now the thing about Lisp though is that it evaluates lists as the first item needs to be a function or a procedure. So if I hit enter here, it'll actually give me an error because it says there's not a procedure. And that's true. 1 is not a procedure, so I can't just write 1, 2, 3, 4, 5. I need to start with a function. And so one of the things that we can do is we can say like 1 and 2. We can add 1 and 2 and get 3. So we start off with a function and then we give some data. Now what's great about this is that we're not limited to 2 numbers. We can actually give it any number of numbers to add together, and it will do it for us. So that's a pretty powerful part of Lisp right there, is that it kind of breaks away from having to use this infix notation that we've learned since we're, in first grade. It allows us to use this prefix notation, which gives us a little bit more flexibility in how we do our math. And we can use all the normal operators, so we can add the multiplication of 2 and 3 together, and the subtraction of 9 and 7, and we get 8, right? So we can do all of our math that way. We can even do things like the canonical hello world program, so we can just do printf hello world, and it will print out hello world for us. So that's kind of an introduction to the basics of how to use these lists. Now what if I want to actually have a list? What if I want to have the list 1, 2, 3, 4, 5? How do I get that list? Well, in Lisp there's a thing called quoting. So if we quote a list, say 1, 2, 3, 4, 5, then it will actually quote that list. And we can see there's actually a shortcut for quote. We can just use this single quote operator that quotes our list and makes it pure data instead of being a function. So let's do that. Let's define things, right? So how do we create variables? Let's do that. Define x equals 3. So now we've defined x as being 3. If we type that in, we can see that x is 3. So let's do that with our list though. Let's create my list, and we'll do 1, 2, 3, 4, 5. And we'll create another list. Define my list 2, and it will actually be a list of lists. So we've got 1, 2, and 3 and 4, and 5 and 6. And then let's create one more list. Another powerful thing about lists is that they don't have to be all the same data type. They don't have to be homogeneous. We can actually have anything that we want, so we can put things like 12, hello, other lists inside of there, and we can take a look at all of these, right? So if we type in my list, we can see that it is the list 1, 2, 3, 4, 5. We type in my list 2, we see that it is a list of lists of numbers. And if we type in my list 3, we see that it is just a heterogeneous list, right? So we have a list of multiple things. So a list can contain whatever we want in there. That's pretty powerful. So now how do we, break apart these lists and build them up? Because in our programs we'll want to have certain loops where we build lists, that we want, or break apart lists. Well, let's start with constructing a list, right? So you construct a list by using cons. So we can cons, say, a number onto an empty list, and it will create the list with one item in there. We can cons 1 to the cons of 2 to the empty list, right? So cons 2 actually creates the list with 2 in it, and then we can add 1 to it, and that will create the list 1, 2. So we can build lists this way. We can actually build lists of lists this way, and we can put together let's see, let's do another one. Let's actually copy this. We can, and like I said before, they don't have to be homogeneous, right? We can put other things in there, right? And so we can have a list with a word and a number, and that's essentially how we build lists, right? We can add things onto the front. Notice that we're adding hello onto the front of this list with 2 on it. Right, so how do we break things up? Well, if we add things onto the front, we should be able to take things off the front. And the way that we do that is with a function called char. So if we take char of my list, it will actually take the first item of my list, right? So the first item is 1, and it put out 1. Now the reason why it's called char is just a historical accident from the 50s and 60s. The way their computer was built, they ended up having they ended up creating weird names. But you can think of char as being the first element, right? So if you get this first element, you should be able to get the rest of them too. And they do have a function for that. And so that function is called cutter. So if you take the cutter of my list, it'll actually give us the rest of our original list. And these things will also work for all of our other lists too. So if we do my list 2, which was a list of lists, it gets the first element, whatever it is. So if it's a list, it'll get that, right? And we can do the cutter as well. So if we do cutter of my list 2, then we get the rest of a list. Now, what's interesting about Lisp is that if you take a look at it, all right, these lists look a lot like programs, right? Some of them may not have functions inside of them, but they do kind of look like programs. And indeed, we can create a list that is a program. So if we say, if we define the square program as just being the list of this program, now we have a list that is a program. So if we write square program, we actually get a list. And we can actually break apart this list if we want. We can take the car of square program, right? And we can take the cutter of square program. And now we can actually get any item that we want out of this. We can actually get anything that we want out of this, right? So if we want to get say, oh yeah, I didn't write square program. This would just be a list definition. Let's actually write a square. How would we write our own function? Let's do that. So define, let's say square of x is just x times x. And so the way that we write a function is the first list has the name of the function and then any arguments or parameters for the function, and then the second list is just the body of the function. So if we do that, we have square 3, right? And we can do square. Oh, it turns out for math we can actually have anything that we want. We can even have fractions and decimals and things like that. Oh wait, let's see. I think oh, square only takes one argument, right? So I define it as only having one argument. But we can have square, right? We can have fractions, we can have decimals, we can have integers, we can do all kinds of things that we want with that. So a square program, right? The square program would be this, and let's do that. Let's make that a program. So if I do square program, now we have our square program, and we can do car of our square program, and we can do cutter of our square program. Now we can actually get any element in our list using just car and cutter, because we can take the car of the cutter of our square program. And if we do that, if we remember, we go inside outward. So if we take the cutter of our square program, the cutter of our square program is the rest of the program without the front part, right? And then if we take the car of it, which would just be the first part of this, then we would get this part, right? And in fact, if we run it, that's exactly what we get. And we can go even further. We can say we want the car of the cutter of square program, and it would give us that inner part, right? Now that maybe sometimes you want to be able to get some of these things, you don't want to write out all of this car cutter stuff. So there's actually built-in shortcuts for these kinds of things. So if we want to get the car of the cutter of something, we can write that, and it will get the car of the cutter. And if you want to get the car of the cutter, you can write that. It's not super important, but it's a nice little shortcut. And you can write your own shortcuts if you want to, right? You could create your own little word, and it does the car, the cutter of whatever. And you could have your own little shortcut. So this is actually pretty powerful because I'm actually able to take apart I can take a function apart, and I can build up a new function if I want to. Now the other powerful part of Lisp is that we also have eval. So if I have, say, let's create a little function that adds two numbers together, define a little program. Yeah, let's just call it program, and it will add 3 and 4. Right, so now I have a program. Actually, it'll be a list, right? So now we have some data. So if I write program, it just has 3 and 4. But if I do eval program, it will actually execute it. And actually eval will try to run any list as a program. So I can write 1, 2, 3, 4, 5, right? So this is a list, right? Because I've quoted it. And if I run eval on it, it will actually run it as a program. So this is another powerful part of Lisp, is that the programs are data, and data can be programs. And this property is called homoiconicity. And Lisp is one of the few languages that actually is homoiconic. And it's a very powerful thing, especially, and it was a very exciting thing back in the 60s, because they used Lisp for research in artificial intelligence. And one of the things that you might want to be able to do with an artificial intelligence is have an artificial intelligence write programs, right? So Lisp, we can actually build up other lists which can be programs. So we can actually write our own programs with the program, and then we can actually execute them. Right? So you can imagine you could have an AI that writes programs, it can test them, see which programs are better, throw away bad ones, keep the good ones, and maybe improve on the programs that it writes. So you could have an AI that makes itself smarter over time, right? And Lisp makes that very easy to do. It's much harder to write an AI in, say, C or C++ that writes code and evaluates it, right? It would need to write it into a file and compile it and all that other stuff, right? It would allow to, on the fly, write new programs, test them out on the fly, which is very powerful. Let's see, I've probably taken up too much time already, so I'll stop here. But that is kind of an introduction to the power of Lisp. I would recommend taking a look at it if you've never used a language like this that uses the functional paradigm. It's quite powerful, and it'll actually change the way that you think about programming. And many people would say that if you learn a completely different paradigm or a completely different language, it'll help you become a better programmer. I would say that's true. If you can learn Lisp and maybe Haskell and a few other languages that are quite different, that force you to think differently, it'll help you be a better software developer. So thanks for watching, people. Till next time.